Hello everyone, this video is about transformations. Here we have the shapes of simple graphs: linear, quadratic, square root, quartic, cubic. Sliding the translation is sliding the whole graph. You can do it vertically or horizontally. We can use vector notation or we can use function notation. For horizontal translation, if you slide 1 unit to the left, this is the original graph. Sliding 1 unit to the left, we get this. So all the x values are subtracted by 1. And if you move it to the right, all the x values are added by 1. So you slide to the left, slide to the right. If you slide to the left, this is the vector notation. Slide to the right, this is the vector notation. In function notation, when you slide to the right, you see we have on the inside you have +1 on the inside, and here if you move it to the right you have minus on the inside. So we replace the x with x plus 1 and x with x minus 1. So in conclusion, we have the change is plus minus a number inside the parentheses. For vertical translation, for example, 1 unit down, 1 unit up. If you move the graph 1 unit down, this is what you get, and from this original move it 1 unit upwards, this is what you get. The vector notation -1 if you go down, 1 if you go up. And the function notation, it's on the outside, on the outside of the parentheses, outside of the parentheses, minus down plus up. So this means exactly like the original x squared, but you have -1, exactly like the original, but you have +1. So for example, we have this original and we are translating 2 units to the left, horizontal, so it's on the inside, and left means plus. So you replace this x with x plus 2. Upwards means you the transformation is y equals f of x, but you have 5 this is translation, so +5 on the outside of the parentheses. So just like the original x cubed plus 4, exactly the same, but we have additional +5 on the outside. And if we have this original and we have this result, if you want to know what kind of transformation we have here, just express it in this form. So of course we have to use the original form, but we have +12 actually. So that is the transformation. We have plus side on the outside, so this is vertical up. For positive we go upwards, and we go 12 units for the number. Let's say we have the original and we have this result. If you want to know the transformation, express in this form, so it's going to be in the form of x minus 2, but the x here is actually x minus 5. So the change is you replace x with x minus 5, and on the inside that's either left or right. Minus means you go to the right. And 5 units. And for the last example, we have this transformation. So 1 unit to the right, 2 unit upwards. Using that exactly the same form, we have inside we replace with x minus 1, outside we have +2. This means the transformation is x minus 1 plus 6, and this must be -9, so we're not changing the value. So the original function must be x plus 6 to the power of 10 minus 9. For stretching or squeezing horizontally or vertically, we use x direction, y direction, that's the proper wording. And the center of the stretch is always the x-axis or the y-axis. In notation, we have a multiplication on the inside or on the inside or outside. Inside horizontal, outside vertical. And for horizontal, this is a factor, the reciprocal. So this is the original. For the horizontal stretch, we get this, and for the factor k equals 2, we get this. And for the k equals 2, it's like smaller or skinnier, and if the factor is 1/2, actually we stretch it, it's like wider. And for vertical, this is the original. This is if we make it shorter, because 5 becomes 5/2, 2 becomes 1, we divide the y values by 2, and this is when we multiply the y values by 2. And for vertical, it's on the outside. 1/2 means shorter, 2 means taller. For example, we have horizontal on the inside, k equals 2. For horizontal, we use 1/3 f of 1/3x. So we replace x with 1/3x. For vertical, it's on the outside. 4 means just 4, so we multiply everything by 4. For this change, 5x, so it's horizontal because it's on inside, and the factor is 1/. And here the change is, we actually multiply everything by 6 from the original here. So 6 on the outside, vertical, the case is just 6. And here the change is, we have 7 on the outside, so the original graph must be 1/7 times x minus 5 whole to the power of 10 minus 1. So the original graph is 1/7 x minus 5 to the power of 10 minus 1. For reflection, flipping upside down or left right, the mirror is always the x-axis or y-axis. Notation is, we have minus inside or outside for vertical or horizontal. So this is a vertical reflection from the original to vertical reflection upside down, from original to horizontal, left right. We have a minus outside for vertical, inside for horizontal. So for example, here we have horizontal, so it's on the inside. On the inside we have a minus, so we replace the x with minus x. Vertical means on the outside we have minus, so minus times everything. Vertical, again, it's on the outside, so we have minus times everything. So yeah, that's it. And let's say we have this original and we know that this is the result. The change is, we replace x with minus x, so on the inside it's horizontal, and here the change is on the outside, so it's vertical. So this is the change, and the original is therefore y equals minus x minus 5 to the power of 10 plus 7, because if we multiply everything by minus, we get this. So in conclusion, if it's horizontal, the change is inside the parentheses, vertical outside. Translation means you add or subtract. Stretch means times, reflection means minus. So for all of these types, horizontal on the inside, vertical on the outside. For horizontal, it's always the opposite. So plus means to the left and minus means to the right. For vertical, it's like the natural direction. Plus means you go up, minus means you go down. And for horizontal again, when the coefficient is 2, the factor is actually 1/2. So it's getting smaller actually. We are squeezing. 1/3, again, the reciprocal is 3. So if the coefficient is 1/3 inside, that's horizontal, and it's getting wider 3 times. And for vertical, it's naturally, so times 4, the case is 4, times 1 over 5, the k is 1 over 5.